Hello students, and welcome to our lesson on solving quadratic equations with the zero product property. Today we're going to be using that zero product property to solve equations, and we're also going to use substitution to solve quadratic equations where we're still going to use the zero product property, but it's going to be a little less obvious how we get there because the original problem is going to look just a little bit more complicated. So what we're going to do is we're going to use substitution to make it look exactly the same as the other problems we're solving. And then we'll use substitution to put it back into the form it originally started with. So the application we are building up to, you want to frame an 8 by 10-inch photo of you and a sea otter. The frame has a uniformly thick band that goes around the photo, and the total area of the frame is 120 square inches. What is the uniform thickness of the band? So you can see my little doodle there. We have an 8 by 10 photo with a frame around it. And you can see the dimensions here, x and x, represent what would normally be a little white band that goes around the photo. It really makes the photo pop. And so we can write the dimensions of the frame based on this information, where the height of the frame is going to be 8 plus 2x, because there's an x on top and on bottom in terms of thickness there. And the width of the frame is going to be 10 plus 2x for the same reason. We again have an x on the right and an x on the left because the band is equally as thick on both sides. So then when we set our area up, we're going to have that the area of the frame is 8 plus 2x multiplied by 10 plus 2x, and this total area needs to equal 120 square inches. We will come back to this one at the end and unravel that thing and solve it for x, but our setup is that the area of the frame is going to be 8 plus 2x times 10 plus 2x, and we set that equal to the given area, which is 120. All right, let's see how we actually use this zero product property. So a quadratic equation is an equation containing a second degree polynomial. So we might have ax squared plus bx plus c set equal to 0, for instance, where the key that makes it a quadratic is the fact that it has an x squared as its highest power. A, B, and C in this equation are real numbers, and what's important is that A cannot be 0, because if A is 0, then we don't actually have a quadratic equation, because that would mean the A term right here just goes away. So if we only have bx plus c, that is a linear equation, no longer quadratic. Standard form is what is shown where I was just pointing, okay, over here, where we have all the terms of the expression written in decreasing order based on exponent, and on the other side of the equation, we just have 0. So what makes it standard form is the fact that we have the standard form of a quadratic here, and it's set equal to 0. What's very important for this lesson in particular is that we have 0 on the other side. Because the zero product property, which is what this lesson's all about, states that if you have A times B equals 0, then either A is 0 or B is 0, or both. Okay, so where does A times B come from? Well, what we're going to be doing is factoring the left side of all these equations. So that way we have the product of two factors, and then we will set each factor individually equal to 0. So let's see what I mean in number 1. In number 1, we have m squared plus 8m equals 0, and we want to solve for m. What we're going to do is factor the left side by pulling out the GCF. So GCF is m. We factor that m to the front, and we have m plus 8 left behind. Notice now that we have the product of m and m plus 8. So I can call those a and b respectively, and we have now that a times b equals 0. So what the zero product property tells me is that I can split this into two problems. Either a is equal to 0 or b is equal to 0. But we don't want to talk about a and b, we want to use the actual values we have. So either m is equal to 0 or m plus 8, the second factor, is equal to 0. Okay, so that's the power of the zero product property is we just took an equation that had a product and split it into two separate equations. And notice each of these individually is very easy to solve. M equals 0 is already done. M plus 8 equals 0, we subtract 8 from both sides, and we get m equals negative 8. So now that one's already solved as well. So once you've split problems up using the zero product property, generally speaking, getting to the answers after that is quite easy. In number two, we just have to avoid a pitfall. Okay, we have p squared equals 6p. The common mistake is students will divide both sides by p. But I'm gonna make a note here. Don't divide by a variable. Okay, the reason for that is, what if the variable is 0? We know that we're not allowed to divide by 0, but when we write a letter down instead of 0, it feels like it's not wrong. Okay, but that variable, you don't know what it is, so 0 might be the value of the variable, in which case you just broke a rule. You're not allowed to divide by 0. So instead what we do is we write the equation in standard form. We move everything to one side, so I'm going to subtract 6p from both sides to get p squared minus 6p equals 0. And once we have it in standard form, then we factor it. So I'm going to factor out the p to the front. P times p minus 6 equals 0. And now, just like in problem 1, I can use the zero product property to split it into two problems, where either the first thing, p is equal to 0, or the second factor, p minus 6 equals 0. P equals 0 is already solved, so nothing to do there. For p minus 6 equals 0, I add the p to both sides, and I get that p equals 6 as my other solution. So far for problems 1 and 2 here, I've had two solutions in each case. If you had solved number 2 by dividing both sides by p, you would have instantly gotten p equals 6, but you would have missed out on the possibility that p might be 0 also. All right, now we're going to do the same thing, but this time we're going to have to actually factor using split in the middle or the AC method. So for number 3, we have x squared plus 5x equals negative 6, and we want to solve for x here. Our first step is always going to be to rewrite these things in standard form. So I'm going to add the 6 to the other side. Okay, we always want standard form. So get standard form. Step 1 all the time. Now that we have standard form, now I want to factor that left side. So I'm going to make a little t-table. The AC method tells me to multiply the A value times the C value, which is 6, and the B value goes on the top right, which is 5. I then find all the factors of 6, so 6 times 1, 2 times 3, negative 6 times negative 1, negative 2 times negative 3, and that's all of them in this case. And then on the right side of the table, you add them together to see which one gives you 5. 6 plus 1 does not equal 5, but hey, 2 plus 3 equals 5, which means I have found my pair of numbers. 2 times 3 equals 6, and 2 plus 3 equals 5. That means 2 and 3 are my magic numbers in this case. So now, if we needed to split the middle, we would split 5x, the b term, into 2x plus 3x. But because the a value here equals 1, we don't have to do any of those splitting the middle steps. Instead, we can go straight to x plus 2 times x plus 3. And this is still set equal to 0. Remember though, I only get to skip those steps because the a value is 1. All right, so now we have the product of two factors equals 0. So the zero product property allows me to rewrite this as x plus 2 equals 0 or x plus 3 equals 0. Solving each of these individually, I get that either x is negative 2 or x is negative 3. So I have two answers to this problem, negative 2 or negative 3. But notice the steps are the same as before. We write it in standard form, and then we factor the left side. All right, number 4 is already in standard form. We have 20y squared minus 19y plus 3 equals 0. So we're already in standard form, but our a value this time is not 1. So we're going to have to actually split the middle when we do this one. If we multiply a times c, 20 times 3 is 60, and our b value is negative 19. We now need to find factors of 60 that add up to be negative 19. But whenever the b value is negative, like this is, and the ac value is positive, we know that both factors are going to have to be negative. Because if I tried, for instance, 6 times 10, 6 plus 10 is 16. That's a positive number. There's no way for me to add two positive numbers together to get a negative. So instead of trying positive numbers, I'm only going to try the negatives. So negative 6 times negative 10, but -6 minus 10 is -16. That doesn't quite work. So then I might try -20 and 3. Sorry, -20 and -3. But -20 minus 3 is -23. That's not quite right. So then -15 times -4. Hey, -15 minus 4 is -19. So -15 and -4 are what I'm going to go with. All right, so now I split the middle. -19y I rewrite as -15y minus 4y. And then I write the rest of the problem around it as it was. So 20y squared in front plus 3 in back. And then this is set equal to 0. Now I want to group together. I'm factoring by grouping now. So I group together the first two terms and the last two terms. So I'm going to group together 20y squared minus 15y. And when I group together the -4y plus 3, I just have to make sure that I handle the negative sign correctly. So I can either write plus and then parentheses -4y plus 3, or I can leave the negative sign there. Okay, but then when I write this set of parentheses, I have to make sure to factor the negative out of both the -4y and the 3. So when I do that, I can write positive 4y minus 3. Or just be careful that this negative sign right here is only on the 4y. So when I distribute this negative sign, it needs to give me back -4y plus 3. So I had to take a negative sign from this 3 over here. All right, now we pull a GCF out of each term. So 20y squared minus 15y, I can pull 5y out to leave behind 4y minus 3. The other set of parentheses already is 4y minus 3, so I don't need to pull anything out. I like to pull out a 1 still, even though it doesn't do anything. I like to visually have that 1 there, because then in the next step, when I pull the 4y minus 3 to the front, I can see that 5y minus 1 is what I left behind. So even though this number 1, I didn't technically pull anything out, by writing that 1 there, it reminds me that I need to have the -1 in my next line. All right, so now zero product property gets used. We have the product of two factors is equal to 0. So we split it to be either 4y minus 3 equals 0 or 5y minus 1 equals 0. On the left, we add 3 to both sides to get 4y equals 3. And we divide by 4 to get that y is 3 over 4. On the right side, we add 1 to both sides to get 5y equals 1. And then divide by 5 to get that y equals 1/5. So again, we get two answers, but in this case, our two answers are both rational. Okay, we have fractions in both cases. Y is either 3/4 or 1/5. Hopefully that one illustrates why you should never be doing guess and check. Imagine looking at that quadratic equation at the beginning and trying to figure out what y is by just guessing random numbers. I think it's going to be a while before you guess 3/4 and 1/5. So don't try guess and check. That's the moral of that story. All right, using substitution to simplify equations. Substitution allows us to rename, quote unquote, rename part of the equation so that it appears to be easier to solve. We just have to remember to convert back to the original name at the end. So in these problems, I don't make you figure out what to substitute with. Because this is our first time seeing this, I want to make it clear what substitution I want you to make. So I actually wrote it in the questions directly. In the future, though, you will, especially when you get to pre-calculus and you deal with trigonometric equations, you won't be told what to substitute for. You will have to look at an equation and just recognize that it's in a quadratic format. But for right now, I made it nice and clear what I want you to substitute for. So number 5 says use substitution, y equals x squared, to rewrite and solve the equation x to the power 4 plus 5x squared plus 4. So what we're going to do is we're going to replace x squared with the letter y. Okay, so instead of writing x to the power 4 plus 5x squared plus 4, I'm going to replace x squared right here with the letter y. So now I have something plus 5y plus 4 equals 0. But if you're wondering why I didn't write the x to the 4th yet, it's because we can rewrite x to the 4th using this same substitution. I'll give myself a little more room here. x to the fourth in front, this is actually x squared squared. Okay, so if I replace the x squared on the inside with y, then I can rewrite this whole thing as y squared. So the key to recognizing that you have something that's in the form of a quadratic is the exponents start off at 0 over here. We have a constant on the right, and then we have something that when we double it gives us the first exponent. So the key is that the exponents get doubled from right here 2 to 4. Okay, because I doubled 2 to get 4, that means we are in a quadratic form. All right, so now we're going to solve the quadratic that I wrote down below. Y squared plus 5y plus 4 equals 0. If we solve this for y, we're going to get that y, let me go back to black pen. If we factor this, we have y plus 4 times y plus 1 is equal to 0. Now, why did I do that so fast? Well, the a value is 1. So when the a value is 1, we're in the shortcut version of the questions, where all we have to do is find two numbers that multiply to give us the c value and add to give us the b value. So in that case, the numbers are 4 and 1. I can now split this problem using the zero product property. Either y plus 4 equals 0 or y plus 1 equals 0. On the left, I would get y equals negative 4. And on the right, I would get y equals negative 1. So I have two solutions. The issue, though, is that the original question has x in it, and my solutions just now have y in them. So what I need to do now is substitute back for what I originally substituted before. So we use the fact that y equals x squared. So now, wherever I see the letter y, I'm going to replace it with x squared. So x squared equals negative 4, or x squared is equal to negative 1. Okay? Now, this next step I'm about to do, we haven't actually learned yet. Okay? In the next lesson, we are going to learn the square root property, which allows us to finish this problem off. Technically, we don't know that yet. So as of right now, okay, we know how to get to this place where I put the arrow, but in order to go from where we are now to the next step, this is actually going to be covered in the next lesson, which is lesson 25. Okay, so it's okay if this next step doesn't make any sense to you. It will when we come back to it and revisit this after the next video. So what we want to do to get x by itself, now that we have x squared equals negative 4, is square root both sides. When I square root both sides, I'm going to get that x is equal to plus or minus the square root of negative 4. Where a lot happened there, and again, we're going to practice this in lesson 25, but when you square root x squared, you just get x, and when you square root negative 4, you have to put a plus or minus in front, because it's possible that the answer is both the positive or the negative version. All right, and then to simplify this, we learned that the square root of negative 4 is 2i, so we can say plus or minus 2i right here. Similarly, on the other side of the equation, we can square root x squared equals negative 1 on both sides to get x equals plus or minus the square root of negative 1, which means x equals plus or minus I. So we still end up with, in this case, 4 answers because plus or minus on both sides, so there's 2 answers on each side of this. But those last couple steps really are a lesson 25 topic. So don't worry, the important thing there was practicing the substitution that we did in the beginning steps of the problem. All right, now number 6, we want to use substitution. Y equals x plus 4 to rewrite and solve the equation we see down below. So what we're going to do is replace x plus 4 wherever we see it with the letter y. So I see x plus 4 right here and x plus 4 on the right. So I'm going to rewrite this equation as y to the power 2 because x plus 4 was squared. So now y is squared plus 3 equals negative 4 times y. All right, this doesn't look too bad now. In order to be able to factor this, I need to first write it in standard form. So I'm going to say that y squared plus 4y plus 3 is equal to 0, where I just add that 4y to both sides. Now I need to factor it. So again, we have an a value of 1, just like the previous problem. So when I factor this, I can just find two numbers that multiply to give me 3, but add to give me 1, or add to give me 4, sorry. Those two numbers are 3 and 1. So I'm going to have y plus 1 and y plus 3 as my two factors. When I split this using the zero product property, I get either y plus 1 equals 0 or y plus 3 equals 0, which if I solve each one of these, either y equals -1 or y equals -3. But we don't want y as our answer, we want x. So now I have to go backwards and substitute the letter y for what we originally substituted for, which was that x plus 4. So down here at the bottom, either x plus 4 is equal to -1, or x plus 4 is equal to -3. In each of those cases, I subtract 4 from both sides, so either x is -5 or x is -7. So on that one, I end up with just two answers. If you're curious, by the way, you will learn this more in college algebra, but the way I know how many answers I'm going to get from the beginning, this equation I just did, number 6, had an exponent of 2 as its highest power, so we expect 2 answers. Number 5 had an exponent of 4, so we expect 4 answers. All right, now we just got to finish off that title slide. You're framing a photo that is 8 by 10 inches of you and a sea otter, and the frame has a uniform band, which we labeled as width x, all around it. So our two side lengths of our frame are 8 plus 2x and 10 plus 2x. That allowed us to write the area formula, 8 plus 2x times 10 plus 2x is equal to 120, the area that we were given. And so now we need to solve this. So what we're going to do first is get this into standard form, which is the most work that we've had to do for any problem so far. In order to write this in standard form, I actually have to expand the left side first and then subtract that 120 over. So to expand that left side, we're going to multiply 8 times 10 is 80, 8 times 2x is 16x, 2x times 10 is 20x, and 2x times 2x is 4x squared. And I still have 120 on the other side. If I rewrite this in descending order, I have 4x squared, 16x plus 20x is 36x, and then plus 80. This is equal to 120 still. I can now subtract that 120 over to get 4x squared plus 36x minus 40 is equal to 0, because I subtract the 120 from both sides. And now we have to try to factor this. What I taught you guys in a previous video is to always try to find a GCF and factor that out first. This is no different. Everything here is divisible by 4, so we are going to pull out a 4 from both sides. Or sorry, from the left side. So we pull a 4 to the front. That leaves us with x squared plus 9x minus 10 is equal to 0. And because we have an equation, we can actually divide both sides by 4. So if I divide everything here by 4 on both sides, divide the left side by 4, and divide the right side by 4, that 4 sort of just goes away. Okay, it doesn't technically go away, but it divides out on both sides. And because the right side is 0, we're left with x squared plus 9x minus 10 still just equals 0. So it's almost as if the 4 just disappeared, which is very nice. It's a good property of equations. All right, now we have an a value of 1 now. So when we factor this, we can use the shortcut. We need two numbers that multiply to give us -10, but that add to give us +9. And so we might try -10 and +1, but realize that doesn't quite work. What is going to work is x plus 10 and x minus 1. So then we set each of these equal to 0. That is either going to give us that x plus 10 equals 0, so x equals -10, or x minus 1 equals 0, so x equals 1. So now the question is, hey, we got two answers, but this is a real-life application. So do these both make sense? And the answer is no. So the uniform thickness of the band is what we just solved for, but notice that the thickness is a distance. So a distance cannot be negative. So we have to throw away at the end here, x equals -10. That one is not possible. Okay, the band can't be -10 inches wide. So instead, we only get one answer here, which is that x equals 1 is our solution. So the band is 1 inch wide. All right. And that's all I have for you today, friends. See you next time. And I hope that you learned that the zero product property is a very powerful tool that we have.